An amusement park ride consists of a vertical cylinder that spins about a vertical axis. When the cylinder spins sufficiently fast, any person inside it is held up against the wall. The coefficient of static friction between a person and the wall is mu, the mass of the person is m, and the radius of the cylinder is r. Calculate the critical angular velocity omega of the cylinder, which the person will not slide down the wall, and the frequency of the person. So while it is spinning, angular velocity is omega. In the vertical direction, due to the gravity, the person is subject to a downward force mg, and the maximum upward force is Fs. Fs maximum. Fs maximum is mu times mu static times the normal force. In order for the person not to slide down the wall, condition is Fs greater than mg. For the critical case, Fs maximum equals mg, and Fs maximum is given as mu s times the normal force. Therefore, that equals mg. Now, what is n? Normal force. To find normal force n, we need to consider the following. When the cylinder and the person rotates with angular velocity omega, the force provides acceleration omega square r is given as m omega square r. So this is centripetal force, m omega square r. Centripetal force is towards the center, and that is basically the normal force that we are looking for. If that's the normal force, then I go back and rewrite mu s times m omega square r, which is the normal force, equals mg. After simplification, we solve for omega square first, which is g over mu s r, and then omega is square root of g over mu s r. The corresponding number of revolution per time, that is the frequency, can be found from omega equals 2 pi f. So f is omega over 2 pi. When I plug in what I found for omega, f turns out to be 1 over 2 pi square root of g over mu s r.